We're going to talk about the time value of money. Long-term decisions. Well, let me go back to short-term decisions. Short-term decisions, they don't need to have. You don't have to worry about the time value of money. Give me 1 second. Short-term decisions don't need to have the time value of money because the change in the value of a dollar from one day to the next is not very big. It's minimal. As you get further into the future, though, long-term decisions, when you're talking about 5 years, 10 years, whatever, then the time value of money becomes important because the money that you're getting in will have a different value than the money of today. And as time goes on, money becomes, less and less, worth less and less. You talk to your parents about that, how they used to, go out to eat for 50 cents or something like that. Well, yeah, that 50 cents was worth a lot more than 50 cents today. So, the value of money changes over time. Short term doesn't matter too much. The value of a dollar between this week and next week is minimal. But as you go into the future, it gets to be more and more. So the first four pages here, let me see if I'm telling you the correct thing, are on the time value of money, and that's all we're going to do today is talk about the time value of money. And this is something that's kind of assumed that you know. You may already have this in your other classes, but so this is the stuff that we're going to use to start doing the long-term decision making. Okay, so we'll just jump right in and talk about this. Okay, so let's take the first one. Grandma promises to pay her grandchild $1,000 in 3 years. Okay, so in 3 years, Grandma's going to pay $1,000. Oops, too much. And we want to know what that's worth today. And so today, what we're going to do is what they call discounting it back to today to see what it is. So the table we're going to be using is going to be the single payment table. The rate is 6%. And the period's 3. It's a single payment. She's only going to pay us once in 3 years. The discount rate or inflation rate is 6%. And, so that 3-year money getting in 3 years. Now, it's not going to be worth as much today because these are future dollars and they're worth less than today's dollars. Okay, we go down to our table and here's a single payment table. So let me highlight that. Wait, I got to move some stuff. No, don't do that. Oh, I did move it. Okay, good. Now I got to find out where I'm at. Okay, so single payment table. Now let's make that a little easier to see. Let's make it green. 3 periods at 6%. And this is going to be our factor. And I'll show you how we use it. What this is telling us is that each dollar that we get 3 years from now at 6% is worth about 84 cents today. Okay, so here's how this kind of works. So we're going to get this in year 3. $1,000. Each one of those dollars is worth 84 cents. And so this is what it's worth today. So in other words, what you can buy today for $840, you can buy in year 3 for 1,000, or vice versa. You can buy for 1,000 3 years from now, you can buy for $840 today. And today is sort of like year zero, I guess. Maybe you think about it. Today, year zero. So this is the time value of money. $3,000 3 years from now is worth $840 today. Each dollar worth about 84 cents. At, given this. Question that? Okay, let's go to the second one on the page. We're gonna use the same table. Go ahead and figure that one out. The table is going to be the single payment table again. Single and the rate is, oops. I'll make that blue. Okay, so 5 periods, 10%, single payment table, same single payment table, and 621. So each of the dollars that we'll get in year 5, each of these dollars is worth 62 cents. Okay, so in both, you guys even see that? No, you can't really. Sorry. So for the first one, Grandma gave $1,000. It's worth 840. Second one, Grandma gave $1,000. Oops, I didn't put $1,000 in. Let's put that one in. And it's only worth 621. Why? Why is that $1,000 that Grandma's going to give us? Why is it worth less for problem number 2 than problem number 1? There's actually 2 reasons for it. And you can kind of look at the table and see what those are. What does problem number 2 have going against it? Oh, you guys know. The first thing that's going against it is as you go across the top here, for instance, you'll see that as the rates go up, sort of like inflation, it's worth less getting money in the future. The first at 1% is worth 99 cents. As you start getting up, you get to 12%, it's only worth 89 cents. So the higher the interest rate, or think about the higher the inflation rate, the less the money you get in the future is going to be worth. The inflation is going to take some of the value away from that. Okay, also, if you look at the time, even let's go to 1%. So 1 year it's worth 99 cents about. As you start getting down here to 15 years, 20 years, or whatever, you see this starts working less and less. The dollars you receive further in the future become less and less and less. So the further out they go, the less they're worth. You think about it, it kind of makes sense. You think you're getting $1 next year, it's going to be worth more than $1 you're going to receive 20 years from now, for instance. So it has 2 things going against it, and it's the interest rate. The higher the interest rate, the less it's worth, the more it's discounted. think about inflation, and the number of years away. The further away it is, the less it's worth. All right, let's go to problem 3. In problem 3, we have Aunt Susie gives her niece a choice of $1,000 in 3 years or $1,200 in 5 years. Which gift should the niece choose? Okay, so here's the options. We'll put the first one here. I'll put it here. You can put it wherever you want. The first one is this, $1,000 in 3 years, or $1,200 in 5 years. These will be on the single payment table. Rate is 8% for both of them. Periods for the first one's 3 years. Okay, so this is kind of what we're looking at. So these are the choices. All right, so let's take a look down here at the table. Let's do the first one first. %, 3 years. $794. Which is 1,000 times. I just said it and I forgot. 794. Single payment table. Okay, so this is the value of the first one, year 1. There's it, problem 1, or first option 1 maybe is a better way to put it. Okay, and this one's in year 5. She's gonna get the same. Oh no, she's gonna get $1,200 times. Now in year 5, 681. $817.20. Okay, so this is in today's dollars. So option number 1, number 1 here. This will be 2. Okay, so number 1, you could, what about here? You could have $784 or you could have $817. Which one is the better choice? Yeah. So this will be the better choice. Question there? Okay, let's jump down to number 4. 4 is a very similar one. It's Aunt Susie again. There's one thing different though, and that is the interest rate is 12%. Everything else is the same. Oh, what did I do here? I messed it up. Bah. Okay. I take my medicine, and we're trying to get lazy here. Rate 12%. So the now we go to the table. Now we're going to look at the factor for 12%. All the way over here. Let's make that blue. How about? So 12%. So here's the 3 years. 7, 12. And here are the 5 years. 0.567. And the second one needs Mr. Calculator. $6.80 and 40 cents. Okay, so which one would you rather do? Number 1 or 2? 1. Now, say, well, okay, why do we do that? Well, here's why we did that. The discount rate can have an impact on your decisions. So, while at 8%, you're better off with the 5-year option. Under the 12%, you're better off with the 3-year option. So the interest rate can have an impact on your choice. And think about business for the long-term decisions. That can have an impact on your decision, your long-term decision. Any question there? You guys may have already had some other classes.
You scroll just a second.
Yeah. And you guys need to take a picture. Do you want me to?
You're good.
Okay.
Thank you.
Anyone else? I don't know who came in when. Do you need the pictures of the first page? Here's the first page.
No, I got it.
Do you need it?
I got it.
You got it? Okay. Okay. All right. This is the, yeah, I get it. You have the second page yet. Okay, now let's go to number 5. Uncle Fred. Promise promises to pay his nephew $1,000 at the end of each year for the next 3 years. The discount rate is 8%. And what's his Uncle Fred's gift worth today? Okay, so we're gonna use a single payment table. And the rate is 8%. And the periods are, it varies, 1, 2, 3. Okay, so let's take a first look at the first one. So the first one is 1,000. Year 2 is another 1,000, and year 3 is another 1,000. Okay, so we're going to discount each of those back. So the first year will be 1,000. Oops, no, that's right. Okay, so 8%, we're going to go down to our table here. So the first year at 8% is $926. Oh, don't do that. Okay, so the first year is worth that. I'm going to put in all the arrows just because I'm in an arrow kind of mood. Okay, so the next year is 857 for year 2. Year 3 is 794. Okay, so these all 3 of these together will be our total amount. I'm just going to total them up. So this will be the total. So Uncle Fred's gift will have a total value of $2,577. Right? So that is what Fred's gift is worth. Now you'll notice something about the calculations here. You'll notice they took 1,000 times that factor, 1,000 times this factor, 1,000 times this factor. What you could do is add all these factors up and just multiply it once, right? If you add all these up, it should come out to 2,577. This is where the annuity table comes in. And I haven't told you what an annuity is yet, but we'll go down to the annuity table here at the bottom. And we'll look at 8% for 3 years. And look at that. It is the number that we just figured out for ourselves. That 2 point, let me change it. It looks too much like the other one. Let's make it that. you'll notice that that is the same as this on this table. 2.577. So if we add all these up, so here's what we could do if we use the annuity table, and I'll tell you what annuity is in a second, I promise. An annuity table, we would just take 1,000 times from the annuity table down here, 8%. 9% should not be highlighted. 2.577. And we'll get the same number. So here's what an annuity is. An annuity is when all of the payments are the same. So 1,000, 1,000, 1,000, those are all the same. So that's when we use the annuity table, is when all of those are the same. If they are all the same, we could just add up all the singles and then do it, but there actually is a table that actually does that. This table, the annuity table, it comes right off of the single payment table. This 5.77 is just all of these added up. And it adds it up for us. Now you may think, well, how often are there things that are annuity? Well, and a lot of times there are things that are annuity. Things like loans, things like rent, sometimes salaries and things like that. They're annuities. They get, people get paid the same every month. People get paid the same rent every month. If you pay the same mortgage payment every month or whatever it is. So we can use the annuity table. Now we can always use the single payment table. Always, even if it's not an annuity, you can use a single payment table. But if it is if all the payments are the same, you can also use the annuity table. If these payments are not the same, you cannot use the annuity table. So if you get 1,000 one year, 2,000 the next, 3,000 the next, you can't use it. They're not the same. Then you must use a single payment. So annuities, this is when all the payments are equal. Purposely made that last one all caps and obnoxious so you remember it. So all payments have to be equal. If one of these is not the same, if it's like this, can't use the annuity table. Okay, now for 3 items, that's probably not that big a deal, but if you come down here to the next page, we're almost done with this thing. Yay. If you go back down here to this next page, page 3, I think. Are we on page 3? We are on page 3. Now, here's what's going to happen. So, it's still Uncle Fred. So Uncle Fred is going to pay $1,000 every year. Now it's for 7 years. So could you use a single payment table? Yes, you could. You could do 7 calculations and do this. It would be no fun, but you could do it. So what we're going to do instead is use the annuity table. The rate is 6%. Periods are 7. So let's go down to our annuity table. This is an annuity. They're all equal. Since these are all the same, we can use the annuity table. You can always use a single payment table. We could do 7 calculations, 7 single calculations. But let's try to speed it up a little bit. So we will do the annuity table. Okay, so this is 6% for 7 years. And the factor we're gonna get is 5.582. Okay. So it's sort of like for all years. 1,000 times 5.582 equals, I could do that. Can't even tell which one made it go goofy. I won't put the equal on. I'll stick more. So 5,582. So this is what it's worth today. And this is taking all of those together. Now we could do it individually. We could go up here and use this table and go do 7 periods. You know, we could do that. But it's just much easier. Did I do that right? Yeah, I did that right. Okay, so 6. So yeah, so this would be what it's worth. Okay, last two are a little bit more applied, shall we say. Janet wins a $2 million lottery. Now, we could go all the way out for 20 years. We could we use a single payment table with this? Yeah. Would it be fun? No. Okay, so we could go all the way out for, 20 years doing all this, but I don't think this will fit. I know, I'll put it as 100K. How about that? We don't know what that is. Okay, so we could just say, okay, and then between 7 through 19, all the same. So we could go 20 periods and do it all, but we'd much rather just put in. So we're going to use the annuity table. It's an annuity. The rate is 10% or 8%, and the number of periods is 20. So we can go to our table. It's 8%. It's 20 periods. Yeah, it's time 100,000. So down here we'd say all years 100,000 times. Is that right? Is that 8%? 8%. Yeah, 9.187. I said that wrong. 817. Thank you. So what is that? 900. Oops, 981,700. Ah. Yeah, let me make you larger. But to make one of you guys smaller first. This is a new handout, by the way. I gotta stop doing this. There we go. There we go. Okay. So this is what her winnings are worth. She's not a millionaire, but she's pretty close. And if you know, if you ever do win the lottery, they always give you the choice of taking a one lump sum, and this is how they come up with it. And by the way, you know, the state will give you a one lump sum number that then you can also shop around and see if anyone else will give you a better number. Anyone else will use a smaller discount rate, basically. Okay, now winning a lottery doesn't happen all that often. This last one here, though, yeah, we need to get some space, so I'm going to do a little cleaning up here. Hey, that's not coming up. Okay, are we there? Okay, last one. This is one we're looking for. Sam is working in a bicycle shop. The owner offers to sell the bicycle shop to Sam for 600,000. The shop won approximately 100,000 a year for the next 15 years. Okay, let's take that 20 out of there. That's a typo. That's a cut and paste typo. Up through year. So change this to year 15 if you would. So okay, so we could do a single payment table. We could do make you know, same as before. You know, we could do 15 single payments, but it would be a lot of work. I want you guys to learn to be lazy like me. That's what my real goal is. Okay, so annuity, this is gonna be an annuity table. They're all the same payments. The rate is 6%. The number of periods is 15. Okay, so we're gonna take 100,000 times, and we gotta go to our annuity table. 15 years at 6%. Oops. So 15 years at 6%, is that right? 15, 6%. Okay, 9711. Is that right? 971. Okay, other than my spacing. Come on, move. All right. Give me a chance here. Let me see something. There we go. Hey, it's still not going up. Okay, I'm gonna really mess this up. Just to get it on the same page. Close enough. Okay, so this is what it's worth today. So the owner is offering to sell it to Sam for 600,000. This bicycle shop is worth, I did the math right. It's worth $971,100. $100, I'm sorry. Should Sam buy this place? The owner is offering to sell it for 600. And it's worth 971,000. So should Sam buy it? Let me put it a different way. Suppose someone said, hey, if you give me $600,000 today, I'll give you $971,000 today. Would you want to do that? do that as many times as you can, right? So yes, you'd want to take this, you would say, this would be a buy. You want to buy it. Oh. Let me try a different one. Yeah. I'll put it up above here. Buy. There we go. So yeah, you want to buy this place. It's worth, this is what its value is, 971. They're selling it for 600,000. You would want to do that. Now, if they were selling it for $1 million, you wouldn't want to do it because the asking price would be more than it's worth. And here's a kind of cool thing about cash flows and discounting them like this. Are those two equal? No, they're not. You're close to it, but they're not equal. I was good at the one above it. I thought maybe did something wrong, but no, that's what it is. Okay, so if you can get the cash flows and the interest payment, you can value anything. You know, anything, any business decision, any building you want to buy, any real estate, any whatever. If you can get the cash flows, you can value anything. You know, however strange it is, if you can get the cash flow and interest rate. Now, sometimes you can't get the cash flow and interest rate, but if you can, or get in some kind of an estimate, you can value anything. All right. That is it for today. Any questions on that? So next class, just to give you kind of a heads up, we'll go into some of the longer term decision making stuff, but that won't be until next Monday. Okay, any questions? All right, I'm going to stop the sharing. Hey, my video's off. Must not like me. All right, no questions? Okay, I'm gonna stop the video. And then some of you, where am I? Give me 1 second here. And meeting for everybody.